of this video is called Reasoning Behind Hypothesis Testing. And what I want to do is just kind of get the ball rolling on one of the most important concepts that we'll study in this class. Let's just step back a little bit and think, where we've been. The overarching goal so far, not so far, but recently, has been to introduce you to inferential statistics. And there's two parts of inferential statistics. One is called a confidence interval. And the purpose of a confidence interval is to estimate an unknown value. So for example, if the value of a population mean is unknown, for example, what if the managers at Tim Horton wanted to know the average length of time in minutes that a person has to wait in line for drive-through service. Well, I don't know about you, but I don't know the value of that, and I'd say even the Tim Horton folks don't know that either. So if we wanted to estimate an unknown population mean, such as the one that I just provided to you, what we would do is we would go out and take a sample. And we would use this sample as an estimate of the unknown value. For example, I may want to choose some Tim Hortons at random, choose some random times, and as soon as someone gets in line for the drive-through service, I would set up a stopwatch. And as soon as they got all the way through and received their order and drove off, I would stop that and I would record that time. So this would be the mean of however many customers that I decide to include in my sample. Well, we know that this X bar is just one of infinitely many sample means we could have gotten. So there's nothing really special about it other than it's just the one that we have as our sample. But because sample means fluctuate from sample to sample, we would want to add and subtract margin for error around our point estimate, which again in this case is X bar. The second part of inferential statistics is called hypothesis testing. And at the end of the day, what hypothesis testing does for us is it gives us a very rigid statistical procedure, a technique if you will, that allows us to test a claim about a value from a population, from a population. And in our class, we limit this to what we call one sample problems. So someone may make a claim about a mu, a population mean, or someone may make a claim about P, which is a population percentage. For example, let's say that someone says that it takes 3.2 minutes on average for drive-through service at Tim Hortons. Or let's say that someone makes a claim that 12% of students at Ohio State University are UK fans. Now, we really never know these answers for sure. There's no way to get the value on all Tim Hortons customers because they continue to come in. And it would be kind of hard to go to a university as large as Ohio State University and find out truly what percentage of fans cheer for the University of Kentucky. Well, hypothesis testing gives us a very rigid statistical procedure, technique, by which we can test a claim. Now, the overarching goal here is to measure distance. And at the end of the day, we address this question: how close is our sample to a claim? Now, guys, close can be very relative if you think about it. If I'm standing a foot from someone, well, that can be relatively close. If we don't like the person, maybe that's too close. If we really like the person, maybe that's not close enough. If you take, for example, the distance between two ants, well, a foot away from two ants is, a significant distance. Where if I take two elephants that are 1 foot apart, well, that's pretty close. So anyway, guys, if we measure distance and want to see whether or not our sample is close to the claim, then we have to take special care in how we measure this distance. Well, guys, in statistics, we should know now that we measure distance how? By standard deviations. And once we got into big boy, big girl statistics, in other words, once we got into the central limit theorem, we saw that we changed standard deviations to standard errors. And it turns out that's exactly the way we're going to determine how close our sample is to the claim, which ultimately leads to our decision. So, first thing we'll do is we'll state what the claim is. So let's say, for example, that the Tim Horton folks claim that it takes 3.2 minutes on average for their customers at drive-through service. We suspect the claim. Now, what we're doing right here is we are officially stating what we are going to test. And guys, these things take on big fancy names. This is called the null hypothesis. And this thing right here is called the alternative hypothesis. Now I'm going to present the next video on how we set up the alternative hypothesis, but if you think again, if you reason this through, which is the title of the video, if we suspect this claim giving us reason or motivation to test, then we must think that the mean value is either greater than 3.2. Maybe we haven't had much luck at Tim Hortons, and we think on average it takes longer than that. Maybe we've had a lot of luck at Tim Hortons, and we think that the average is actually less than 3.2. Or let's just say, for example, that we're not really sure. We're just kind of in an argumentative mood, and we just want to test their claim. Well, guys, when we set up a test of hypothesis, we have to determine and officially state what we call the direction of our test. So we have to set up the motivation. So step number 1, officially state what we want to test. And how do we do this? H sub O and H sub A. Guys, the second thing we do and this is going to be the easiest and ultimately the toughest thing that we do. At first, I'm going to make it really easy on you and just tell you how we usually do things. Once we get into what we call type 1 and type 2 errors, this becomes a little tougher. So anyway, step number 2, we set the standard for our test. And guys, this is all about setting what we call an alpha value. And until told otherwise, I want you always to set alpha at 0.05. Now here in probably, 12, 15 videos, we'll get into why we set 0.05, what does that 0.05 mean. But for now, what do I want you to know? That alpha equal 0.05 is the way we're going to set it until told otherwise. And this is the standard for our test. The third thing we'll do is we'll collect a SRS. And guys, SRS just means simple random sample. So we collect a random sample. Now our random sample would probably consist of 3 things: a sample size, a sample mean, and a sample standard deviation. The next part's kind of the fun part, is we compare our sample to the claim. Now, what we get into here, as you might imagine, what statistical technique allows us to compare our claim? Well, everybody's favorite. It goes back to the central limit theorem. So at the end of the day, what happens? We set up a distribution of sample means, and smack dab in the center of our distribution we place the claim of 3.2. So again, bouncing this off of the claim that Tim Hortons claims it takes 3.2 minutes for drive-thru customers to receive their order. We collect a sample from this. Now, if we get something very close in terms of standard errors, there's not much evidence against their claim, is there? Doesn't mean their claim is true. It just means that our sample doesn't provide much evidence against it. Well, if we get something maybe right here, is that close? Well, it's not as close as this one, but it's certainly not as far away as one that we get way down here. So again, how do we determine close? Within the standard of saying that our sample mean is close enough to your 3.2 to where we may still suspect it, but we can't just come out and outright say that we don't believe your claim, as compared to something a long way away from the claim where it's more believable that we're drawing from a different distribution with a different sample mean. So again, we compare our sample to the claim in standard errors. Guys, the fourth thing we do is we make a decision. And the final thing we'll do is we will present what's called a 1 minus alpha % confidence interval. So there's kind of the reasoning behind hypothesis testing, kind of an outline, more of a general approach of what we're going to do.